Okay, session has been started. Good evening, good morning, good afternoon, depending on your time zone. Welcome, everyone. Today, I have the second honor of hosting Marco. Today, we are going to talk about DAX pattern regarding invoice aging, account aging. My name is Salil. I'm also the data platform Microsoft MVP running the Power BI Fabric user group for Turkey. I'll keep it short. I'm handing over to you, Marco. Thanks for accepting my invitation.
Thank you. You're welcome. Pleasure to be here.
Okay. Okay, I think we can start.
Okay, so first of all, good afternoon, good evening, good morning, good lunch. I mean, we have people from different time zone because when an event is online, people can attend from everywhere around the world. And I'm gonna share my screen because I have the title of the session, so it's easier to review the title this way. So this session is about account receivable aging with modeling patterns in Power BI. So let me try to describe the different levels you can have of looking at this session. So the session shows how to solve a practical problem, a practical reporting problem, which is showing a report with account receivable aging. So basically, we want to obtain a particular report I will show you in a moment. And the initial problem is, okay, how do we write the DAX code to solve this? Because when you look at the problem and when you look at the data that you commonly have, you think that you need to create some calculation in DAX. The goal for this session is to show you that in reality, trying to solve the problem just using DAX is not always the best way. First of all, you should think about what is the right data model I have to use for my data. And of course, you might not have the data in that data model, but the thing is, changing the data, transforming the data in a different way so that it is better for the reporting needs that you have is key to make your solution easier to implement and faster in its execution. Of course, it needs some effort because we have to transform data, and sometimes to do that, we can use other tools other than Power BI. In this example, I will show you examples where I made the transformation in DAX, but I can tell you in advance, this is not a requirement. You can use Power Query, you can use SQL, you can use any other tool to transform data. The main goal is to understand that as soon as you can transform your data according to a common, well-known, reliable patterns, modeling patterns, the quicker you find a solution you can rely on. Because of course, at the end of the day, we want to be able to not only having a solution that works, but in case of an issue in the data, we want to be able to analyze what is going on. We want to be able to investigate in the problem. And when your report is just computed in DAX with a very complex formula, every time you have an issue, you spend maybe hours trying to investigate in a particular problem because it's hard to see what happens in the intermediate step of the calculation. So this is also a way to split the problem in different smaller problems, and so we investigate in these problems better. Why am I saying that? Even though you are not interested into account receivable, many of the things that we will see can be applied to many other problems. So the approach to the problem, the way we try to solve the problem is actually what we can use in many other situations. Okay, so this is the framework. And of course, we will see how to solve the specific problem, but also how to approach a reporting problem that seems not easy to solve with the data that we have. So that's the goal of the session. So my name is Marco Russo. I'm part of SQL BI. At SQL BI, we create content about data modeling and DAX for Power BI analysis services and Power Pivot for Excel. You can find a lot of free articles, videos on our website. Of course, we also have commercial training content for more advanced topics, but you will find free video courses for introduction to data modeling, introduction to DAX. These are free courses that you can find on our website. So let me introduce what we're going to do. Basically, we want to do this report. I can show you the final result, so we can start from the end, where this is the requirement. And let's try to analyze what we have in this report. So basically, you see that we have this is called an account receivable report. So basically, we want to see the aging of account receivable. So basically, we had an invoice that was due in a certain date, for example, 30th December, and today is 23rd of January. So the age of that account receivable is 23 days. So considering the due date, the payment date is late. Now, I don't know in your country, but for example, in Italy, this is very common, unfortunately. That's one of the reasons why I prefer to work abroad. But there are countries where this is, pretty much a common thing, or there are customers that are more late than other customers in paying the amount due. So this kind of report shows how much of the amount that the company is expecting is late. And so you see that there are different colors. 0-30 days is this azure, a darker blue for 31 to 60 days, and so on, right? So the idea is when we look at the aging, we can see that let's say, this purple is more than 4 months, is a lot. So these are credits that probably we're not going to see the money very soon, because probably there is something that is stopping the payment. The company has liquidity problems, and so you see that is it because we had data until I think this line or something like that. Everything that comes later is of course only late, because we don't have any new invoices. Our data is actually finishing in, I think, in March or April 2025, where we are simulating. We don't have real data, and that this is the situation that we have. Now, what is the challenge? Every month, you see that the x-axis is the situation at every month. Now, think about this. Every invoice has a due date. Due date is when the bill should be paid, and a payment date when the bill has been paid. Ideally the same day, or maybe the payment date is before, but sometimes it is after. So what we want to see here is, considering, for example, the end of May, the amount of invoices that should have been paid but have not. And we divide this amount in a certain color. Now, the same invoice could be in May, could be in June, could be in July. Imagine that an invoice is not paid for 4 months. The same invoice will be present in different months, maybe with different colors. And now, how do we create this? Because this is just not a simple sum. That's a problem. So at this point, so this is the code we have, and the first issue is that, okay, so what do we have to start with? Because when you look at the problem, when you have to create this report, you might have different data sources. Sometimes you just receive a file that has been prepared by someone in the IT, for example, extracting data from the ERP or the accounting system, and this is just a summary of the situation. In that case, you just have the summary, you display the summary, but it's very hard at that point to go back in time and display the chart that I've shown you. So probably you want to collect the historical data of what happened. And what is the actual source data of the system? If you have an ERP, if you have an accounting system, you will have probably a database with several tables. And the tables that we have are, in case we have this normalized database, the tables that, sorry, I wanted to do this. The table that we have in a normalized database are something like this. We could have a table customer, a table product, a table payment, but then every customer has an invoice, and the invoice can have multiple rows in the detail. Now, This is a common situation. Now, this is a simplified visualization of what you could have in a database that is designed for OLTP, but this design is not optimized for reporting. And even though this design, the normalized model is designed to have something that let's say is consistent in terms of data, but it could have some ambiguity in the way you can interpret data for reporting. It's a long conversation, this one that I don't want to spend time on, but let's say the idea is that in both cases, so we receive a file or we have access to the source database, in both cases, the data is not the best definition of the data that we need for our report. So what can we do at this point? Well, at this point, we can say, okay, what if we have a dimensional model? A dimensional model is what we look for in case that we create a report in Power BI. And in this case, we can have probably a system where we have several fact tables. In this case, we have two fact tables, invoices and payments. And these fact tables are connected by common dimensions. So, for example, the same customer has a list of payments and a list of invoices. The same product is only related to invoices, and the date has a different relationship because we have the invoice date, we have the due date, and we have the payment date. Now, you may say, okay, so we use this model. Yeah, but in reality, this model is good for, let's say, tracking the payments and the invoices. But if you remember, what we want to analyze is the delay between the due date and the payment date. And if you look closely at this model, these two information are in two different tables because the due date is here and it is in invoices if we use this model, whereas the payment date is here in another table. And what we want to do, we want to connect these two tables by using what? By using the invoice number, because we want to measure the delay. And that's something that if I use this model, I'm not saying that it's impossible. I'm just saying that it is more complex than necessary, because the account receivable conceptually is another business entity. Think about this. I go back one slide. In the dimensional model, we have to model one table is one entity, or one business entity should be one table. So customer is one table, payment is done one table, date is one table, product is one table, the invoice is one table. The account receivable potentially is another entity that here is not present. If not, well, in reality it is present because the invoice, the due date of the invoice defines the account receivable. But what happens if there is a payment that is partial or a payment that involves multiple invoices? That makes this much more complex, which means that we have to create this connection that is not present in the data between invoices and payment, just to measure the distance. And then we also have to repeat this calculation because every time we consider a point in time in the chart, remember we had one bar chart for every month, we have to repeat the entire calculation because we have to classify the distance now with a different point in time, because okay, due date is this one, then we have the date of the report. The date of the report is between the due date and the payment date, yes, so we have to measure this distance, and then we have to put the debt amount in the right bucket in the chart. So the idea, when you see this slide, repeating this calculation, just connecting the two fact tables at report time is expensive, and computing this calculation multiple times because we have to create a chart is very expensive. So because we repeat this operation multiple times. So the idea is that we want to reduce, one, the complexity of the calculation, because we want to write a lower amount of DAX code first. Second, we want to improve the performance because we want to reduce the complexity of the calculation at query time, moving some complexity in the preparation of the data. So preparing the data could be slower, could be more complex, and we accept that. So the idea is that, okay, but what should we do in terms of data modeling? What is the goal in terms of data modeling? Here you see, understand the granularity issue, identify the requirements. Let me explain what I'm going to say. What is the problem? Sorry, not what I'm going to say. If I do this demo in a keynote and Microsoft will show, I don't know, Copilot, the last version of whatever product, we will see a demo where this is what we had. This is the source data. Or we have one line for every invoice. And we have for every invoice, a customer, we have a date of the invoice, a due date, and a payment date. Every invoice has been paid for the entire amount, no exceptions. Every payment is a different payment for every invoice, easy. One row has 3 dates and it just works. Okay, this is the demo word, the word that exists only in a keynote in a conference, because this is not the real world. The real world is completely different. Actually, before looking at the real world, let's see, so because this is the demo that doesn't exist. A system, an ERP, is usually a more complex system that doesn't have this situation. So let's take a look at the ERP world. In the ERP world, first of all, we don't have a single table. We have at least 2 tables. One table is the invoices, and one table is the payments, or the due payments. So in an ERP world, what happens? Let me show you this with highlighting a few things. Let's consider, for example, this customer. Litware has an invoice that has a payment term 30 days. What does it mean? So the invoice has the invoice date, and by summing 30 days to the invoice date, we obtain the due date. So the invoice number 1 is here and has a due date of 15th of October, 30 days after the invoice date. But look at the second invoice. The second invoice has a payment term 60/90. So the amount of the invoice is divided in 2 different payments, 50% after 60 days, 50% after 90 days after the invoice date. So for one invoice, we have 2 expected payments. We call these due payments. So these due payments are 2. We split the amount in 2, and these 2 amounts are on 2 different dates. And these 2 different dates are related to one invoice. And then the third invoice, Contoso, is still 15 days from the mid-September. So we go to, but in this case, we have one row. This is simple. So we can see that we have multiple due dates for one invoice, and in the ERP world, we have one payment for each due date. But once again, when you move to the reality is more complex, because in the real world, what happens is that, well, we have the same content of the ERP, but then the customer pays in a different way. For example, look at Litware. Litware has 3 payments. The first, sorry, not this one. The first payment is on the 30th of October. So this payment does not specify, oh, I paid this invoice. We just received money from this customer. And so this 7,000 goes to cover the, let's say, the first invoices that we have here. But actually, we only had one invoice of 10,000. So what is happening is that we have now this due date payment is 10,000, but 7,000 has been paid now here. So this 7,000 is connected basically here. But the other 3,000, where are these other 3,000? Well, these other 3,000 have been paid by the following payment, which is here. So this 15,000 collected this one, and we have other 12,000. So this one here, we are at 11,000. But now of these 18,000, we have other 3,000 that have been paid with a single payment. And then we have the 2,000 later. So in other words, in the real world, the customer could behave in a way that is inconsistent with the way the database has been designed. And so at this point, all the accounts do some acrobatic to fix the data in the ERP world. But imagine you have this information. Imagine you obtain this information from the real world and you want to create a report. It's a total nightmare now, because you have to reconcile this information, and this is very, very complex. what you should do. Well, what you should do at this point, you should not simply, but you should obtain, let's see if I can switch the slide, you should obtain something like that. If you look at the information we start with which are the invoices, the due payments, and the payments, we can figure out that, well, okay, this is the situation we could have. What we want to solve before doing any report, we want to establish a table that has the lower granularity detail, actually the highest granularity detail for the information that we have. So basically, we want to have one row for every intersection of payment, due payment, and invoice, because this way we can make it easier to examine what is going on. For example, if you remember, the first payment is 7,000, which is here. The first payment of Litware is 7,000 here, which corresponds to this line. So we said this is covering invoice 001, but at this point, there is other 3,000 for invoice 001 that have been paid in this payment at the end of December. But this payment was 15,000, so the same payment covered 3 invoices, which are these 3 invoices, these 2 invoices with 3 due payments. So you see the complexity. So we had the same invoice, but different due payments, a different due payment date, and so on. So only by creating this AR detail table, I actually have the information that I want in order to do the analysis, because at this point, when I want to evaluate how much was late, for example, at a given date in October or in November, I will just scan this table once, and I will extract the information of payment amount that intersect with the condition that I will show in a moment, the analysis I want to do, and then I sum the number. So I move the complexity of understanding the relationships between payments and invoices and due payments into the data preparation. Yes, creating another table, duplicating the data if you want, but making it much easier to actually generate the report. Now, okay, so this is a very, very high level overview of what we want to do. So let's see how this should work in terms of a practical way. So the idea is that instead of trying to immediately create the model that I've shown you now. So I go back one slide. Let's say that we have these information, okay, invoices, due payments, and payments. What I'm saying is that instead of going straight to this table with a single transformation, it could be easier to split the problem, also the transformation problem, into smaller problems. And the first problem is, what if instead of relying on different structure, different things, I simply start to collect the relevant events to my model. So in other words, if you think about what we have, I could say, well, in each of these tables, I can extract an event type with a date and an amount, and the invoice number if you want. So in other words, we can try to think of, okay, what if I just create a list of events in a single table? If I do that, I already have something that is easier to analyze. Let me show you what is the starting point in Power BI now, and what we want to do. So let's say that so I presented in the slide a more complex model than what we have in the example in Power BI. So in the example in Power BI, I didn't go at that level of complexity, but we can use the same modeling approach also for that level of complexity. Now, in the model I have in Power BI, I don't have invoices that have 2 different payment terms for the same invoice. So basically, we always have a single date for the entire amount of the invoice, which means that for every invoice, we have 2 dates, the invoice date and the due date. And we have an amount and the customer key. So this is the invoices table. Then we have a separate table, which is payments, where we have for the invoice, we have the amount paid for that invoice. Also, in this case, we don't have the complexity I've shown you where we just have the customer and not even the invoice, but that is just an increasing level of complexity because we should retrieve the invoice number looking at the data that we have. So what is the first, the oldest invoice that we are covering with the payment if you want to implement that? It's just a more complex extraction of the data. But whatever complexity you might have in your model, what we want to do, we want to obtain a table like this, a table where we have a line for each event. And the event has one date, one type of event, and one document. Let me show you what happens if I filter, for example, one document. So if I filter this document, every document has only 2 or 3 events, because for each event we have, for each date we have the invoice date, and we have one value here, invoice date. Then we have the due payment here, and then we have the payment that could be not present. If there are no payments, this line will not be present. So only the events that exist are included in this list. If I create this table, what I get is a classic star schema. So let me go back to another example where I have this one already modeled. Sorry, not here, but here. I lost the page with the model. Here we go, movements. So this is the movement table. So the movement table is connected to date, to movement type, which is a table that has only, in this case, 3 names, and the customer, because we can still look at the individual customer. By doing this transformation that I will show in a moment, but in reality, the transformation is not the important part. The important part is that I split the problem in smaller parts. So the first step is, okay, let's just extract the relevant events by date from the data that I have. At this point, with this star schema, what becomes easy to do is this visualization. If you look at this report has a hierarchy where we have a year, month, day, and invoice number. And then we see the invoice amount, the due payment amount, and the payment amount, which means that now if I filter, for example, one customer, so let's go with a customer name slicer here, and I filter just the customer 1, we can see the situation for the customer 1. We can see the situation for the customer 4, the customer 10, and so on. And if we drill down, we can see the situation document by document. Please note that my measure here is a simple, sorry, not here. This is just the calculated table. The measure here is amount. So what I'm using is sum of amount. There is no DAX code in the report. The report doesn't use any measure in DAX. This is an implicit measure. What I did to achieve this goal. Now, remember, what I'm going to show you is not necessary. So my goal is that first step, I want to obtain this model. How? It's up to you. You can use SQL, you can use Power Query, you can use whatever you want. In the demo file that I will provide you, you just have a DAX calculated table. So I can show you that this movements table has been created using DAX. How? Well, I got a few columns from invoices, but changing the type. In one case, I got the invoice date. Here I got the due date. And then I merged these 2 tables together with the information from the payments. This is a very simple transformation. In the real world, especially if you have the model that we have seen in the slides, the transformation will be way more complex, because for every row in payments, I could potentially split that row in multiple rows, because one payment could be assigned to multiple invoices, multiple due dates, and the opposite, from one invoice I could have multiple due dates, and so the transformation could require a way more complex DAX code than this. Probably I will not use DAX for that level of complexity, because this code could be slow. Now, when you if you want to try the model that I will make you available, this model internally generates fake data, and you can change the volume, the data volume. So if you want to simulate what happens with many more customers and many more invoices, you can just change these numbers in the parameters calculate table, and you obtain a much bigger model. And you can test this way. You can stress test the performance of the measures. Now I will show you that you will not see with these numbers the performance are always good, but as soon as you have much more invoices, you will see that this is slowing down. If we have time, maybe at the end, if I have time, I will show you what happens if we increase the invoices. You will see that without the optimization, I will show you at the end, the performance will be horrible. But so far, I already obtained this report without writing DAX code, if not for the transformation. And I could have made this transformation by using Power Query, by using SQL, by using any other transformation that you are comfortable with. So now, is this table helping me? Absolutely no. If I want to obtain the final result, remember, I want to obtain this result. This is different because this requires a much more complex calculation, because what I have to do is the following. Let's go back to this intermediate step and let me show you what is the content of the movements table for one particular document. So if I filter the document invoice 001 here, yes, this one should be good. So what we have is the following. So the invoice was issued on this date. The payment was due at the end of August. The payment was made 16 days later. So what we have to do at this point is that if we look at the situation in July, we should not consider this invoice. But if we look at the situation at the 15th of September, at the 15th of September, we have a situation where the due payment is active, but the payment is not here. So we should consider the amount of this invoice, 524, as an amount that has a 15 days of aging. So is in the bucket 030. But if you know DAX, you should know that computing the distance between two rows, let's see if I can show you. Computing the distance between two rows, we want to measure the distance between two dates that are two different rows in the same table connected by the same invoice document, the same document number, invoice 0001. This is extremely difficult. I mean, you can write this code, but it's long and it is very, very, very slow, also with a relatively small amount of data. So we don't want to use this model because this model is hard to query for our goal. Again, you have to model according to the reporting requirements. And so this is not a model that is good for our analysis. So now I go back to the slides 1 second because it's easier to think about data modeling when we look at the graphical design. So this is the star schema that we created. Is a classic star schema, is good, but it's good for reporting individual events. The amount of payments, the amount of the total of invoices due in a certain month. This is good, but if we want to know how late is a payment is, that is way more difficult because it's a calculation we have to do document by document, and the document is split in different rows. So, what is the best approach? You remember the table that I showed at the beginning, this AR detail, where instead of having multiple rows for the same document, ideally we have, let's say, one row for each document. But if we have, let's say, one invoice, two due dates for that invoice, and three different payments for those, you have at least 3 rows, or maybe 6 rows, because it depends on what each payment covers. So you could have up to 6 rows to describe just that single invoice. What does it mean? We have to create the meaningful combination of payments, due payments, and invoices so that we create for every row the exact allocation of a certain amount. So even though the payment is like, if you remember, 15,000, in reality, that payment covers 3 different due dates with different documents. Well, we create 3 rows because this way each row is easy to compute, because in each row we just have to find the distance, sorry, not this one, we just have to find the distance between due date and payment date. And we want to filter those rows where due date is less than the date that we analyze and the payment date is greater than. So by using this analysis, we do a single scan for each date we are interested to, and we just do an aggregation. So the code we have to write is very easy. What does it mean? We obtain just another star schema. And the star schema we obtained, though, doesn't have an exact connection with the aging range, because the aging range depends on the date of the report. Think about this. Every row, I go back one slide, every row could have let's say, a delay computed. For example, look at this. Due date, September, payment date, March the following year. Or there are more than 4 months of delay. So we could compute that this payment was more than 4 months late. But if we look at this line in the report for January 2025, where the delay is not 4 months, it's just 2 months, 3 months, something like that, because we just have to measure the delay up to that point, which means that the same row in this table will project different buckets of aging range in different points of the report. That's the reason why we cannot create a relationship between these two tables, because this relationship is different depending on the date of the report. Okay, so this is the. However, this is something that is, let's say, well known, because, so first of all, let's take a look at the result that we obtained in the final model. So the final model has the movements table star schema that we created before. Then starting from this, regardless of what is the initial data source, because remember, we split the problem in different steps. If I reach this point, at this point, I can just copy what I already prepared for solving the problem this way, because I can start from the movements table and I generate the AR detail table. In this case, once again, I use DAX to create this table. You see, this DAX code is a little bit more complex than what we have seen before. I don't want to enter into the detail, but you can study it if you want. But I could have used SQL. I could have used the Power Query. I could have used any other ETL tool to generate this table. You love Spark, you want to use Python, up to you. Once you have this table, though, what happens? Well, at this point, I can create my report, because at this point, I have a star schema. I have this aging range, which is a disconnected table. And let's see if I can show you. If I go to daxpatterns.com, at this point, what I want to implement is simply this events in progress patterns. So basically, I'm moving to a very common, let's say, pattern where I have a list of events with a connection. These events have start date, end date. In this case, is due date, payment date. And we want to analyze the intermediate state of these events. So which, in this case, how many orders were open. But events in progress means that we want to see the state of an event in progress, open orders, due payment, and so on. So in this case, AR aging. So at this point, by just using the data that we have here, we can create this other report. And you see that this report has, for every month, the amount due split by aging time. So, and you can see the bucket here. In this case, I had to create a measure. If you look at the measure here, the measure is open amount. Open amount is a measure that we have defined in this AR detail, and this measure has a certain complexity, I know. However, as I mentioned, I don't have to invent this measure from scratch every time, because this measure, if you look at the code of this measure, you will find that I basically adapted this measure starting from the event in progress. So in the slides, I quickly describe now the events in progress pattern, where we basically say, okay, we have a model that we can, a model that is let's say, that has the same structure and the same requirements of the generic DAX pattern events in progress, which is a mix between a data modeling pattern and a measure written in DAX pattern. So what we have, well, we have 3 dates for each invoice. If you think about this, we have the invoice date. We don't care about the invoice date. We have the due date and we have the payment date. This is the interval that we want to analyze. And the reporting date is what can be different in every point of the report, in every cell of the report. Okay, so in going back to, let's go back to the report in Power BI. Give me 1 second. Okay, here. You see that here we have the sum, we have all the customers, all the invoices and so on. But once again, remember that if I filter one customer, so for example, if I put the list of the customer here and I select the customer 001, you see the behavior of this customer. And I can change this to another customer and to another customer and to another customer. What is happening at this point? We are filtering this customer. We are filtering all the rows that we have in that AR detail table. And my calculation is computing for every cell of the report, how many rows fit the requirements of the cell, which are two, which are the end of February and the bucket 030 days. Then, of course, I can drill down. I can see which invoice was issued which invoice was open at the end of January and was already late between 0 and 30 days. Now, if the same invoice is present, let's say if we have an invoice like this one, here you see that there is an invoice that is 91, 120 days, 270. If I go back in time, 270 here is here, and 1 month before is here. 270. Oops, I lost it. It was customer 10. I don't remember which customer was. Okay, let's see this one. 7777, and here 77. Probably okay. 77 is here. Then is here. Oh, probably we went because we had 31 days. This because this is just the 30 days and not a month. So when we had the month of 31 days, it could skip an entire bucket of 30 days. So it went from 30 days to 61 days. And so we skipped from this point, you see here, 893, 893. So without moving for 1 month in the middle. So probably this does not happen every time, I hope. But there are other cases. Also, this case is still, okay, this one is good. So you see that in March, 496, 496, and 496. So you see that this invoice was in different bucket over time. So the same row has been computed in different points in my report. That's the reason why we cannot create that relationship. Okay. Now, this is the explanation of how the report works, and we can already create our chart. So basically, this chart is the same chart that we have seen in the matrix, but just with a bar chart, stacked bar chart that shows the data in a way that make us able to understand the sparsity of the data that we have. Now, what else? Well, as I said at the beginning, let me try. I don't remember what is the number I should. So now, if I run this with the performance analyzer, and I refresh this visual, you see that this visual is refreshed in 79 milliseconds. Actually, the DAX really 12 milliseconds is good. I mean, is this my data volume? Finished, okay? Beer, party, dinner, whatever, we don't have to work anymore. But what happens if we have a large amount of data? I can simulate a large amount of data by just changing one parameter in this example here. So let's say that we have 100,000 invoices and see what happens. So now we are regenerating everything and I can refresh all the visuals. Now you see that now my DAX query is running in 211 milliseconds. It is a good machine, by the way. So let me try to move these numbers a little bit higher. So let's go to 1 million invoices with 2,000 customers. And let's see if we can stress the system a little bit more. Here we go. Now it takes more time, a few seconds. That makes sense because we are extending 2 tables and probably also the complexity. I hope I didn't do this with a too high value. 1 million. Yeah, it shouldn't take too much. And what I wanted to show you is that at this point, the report will be slower. Now, one of the reasons why it is so slow is because the model I'm going to show you already has the optimization of the report that also requires an additional complex calculation. So let's clear this. Let's refresh the visuals. Let's see what happens. You see that now the DAX query is running in almost 2 seconds, okay? You might say, okay, Marco, this is not bad. Well, but if I increase the volume, this could be 20 seconds, okay? So if I go to 10 million rows, 10 million invoices, it could be like 10 seconds. And let's say that we want to optimize that, right? Well, the reason why it takes so much is because if you think for a moment, we have to repeat the scan of AR detail, 1 million invoices, for every data point in the report. And that's expensive. That's something that cannot be optimized too much. So the idea, and once again, we're not inventing anything because we reuse the pattern. And if this pattern is not quick enough, if I go in DAX patterns, you will see that the suggestion at this point, at the end of this article, we explain, okay, if it is too slow, you can just pre-calculate a few things. You can create a snapshot where you pre-compute the result that you want to obtain, in this case, the open order, in our case, the aging of the invoices for each reporting date. Clearly, we will not compute this for every day. That would be too expensive. But we know that, for example, we are interested in a report every month, so we can pre-calculate the value for every month. And so we create a snapshot at the month level. So what we do, what we obtain, if I create a snapshot, what I obtain is a different model where aging range is now connected, but the same invoice is repeated every month, if it is open, with the delay already computed, with the aging time, the number of days, the aging days already computed. If I look at the content of this table, AR detail snapshot here, let's go here. We have, so if I sort by document, I think that this makes it easy to see what happens. You see that this invoice 007 has 3 rows, and an invoice that has been paid within the due date time is not present here. We only have the invoices that at a given date had a payment that was not completed within the reporting date. So the due date is less than the reporting date, and the payment date is after the reporting date. So in this case, we see that the invoice date is always the same because this is a single invoice with a single payment, and the due date is always the same. So why we have 3 dates? Because the snapshot data shows this row for every end of the month between the due date and the payment date. So because the due date was April, we have April, May, and June. Then the payment is made in July, so we don't have the invoice at the end of July anymore. Marco, but this table is large. Yes, but first, it's only made by rows of invoices that were open at the end of the period. And it's very, very quick to query, because then even though there are rows that are almost similar in different months, there is a compression. So we don't care too much about the duplication of data in this table. Indeed, this table has, let's take a look, almost 2 million rows, okay, whereas the payments table has 1 million rows. So in this case, it's a very bad scenario because I created a model where most of the documents are paid late, right? So that's if you have only, let's say, 10% of the payments made late, the snapshot table is clearly smaller, even though the same data is duplicated for every reporting date if the invoice is not paid on time. So we can take a look. Once again, I repeat this again and again. This snapshot table is a technique that comes from the pattern. I just adapted the code from the pattern, but I didn't have to reinvent the wheel. I just applied the same code that I have found in the article, that I wrote a few years ago, and I just adapted the column names, and I have my model. But if you have a very large table, you probably don't want to do this in DAX. If you have 100 million rows, 100 million invoices, you probably want to do this in SQL. You want to do this in Spark, or you want to do this in Power Query. It doesn't matter. If I obtain this result, now let's take a look at the speed, the performances of this calculation. So if I go to the AR snapshot, which is the same model, the same report, sorry, the same report with same data, but using the snapshot table with the same amount of data, right? So if I refresh the visual, you see that now my matrix is updated in just 10 milliseconds. And let's take a look at the measure that I used. The measure that I used this time is just open amount here. Open amount snapshot is just a simple calculation that retrieves the value of the sum of this column using last date. Why? Because if I have 1 year, I don't want to do the sum of multiple dates. I want to only get the last date in the period. Because I have the value every month, if I choose a quarter or a year, I want to get the last month of that period. But this allows me to create a snapshot with one value every week if you want, because you want to see the weekly trend of this measure. The measure is the same. You just change the density of the snapshot table, and this measure just works. Let's go back to the slides. So this is what we had, and this means that when I have a reporting date, 15th of October, for example, what happens? If I look at my the content of my AR detail table, at that date in October, there are only 2 invoices that I want to include. Due payments is 2, invoice 2, invoice 5. The other 3 invoices are ignored because they are before, they have been paid before, or they have been issued. They have a due date after the reporting date. So the snapshot is the standard modeling pattern we use to optimize this calculation. And at the end, we obtained a simple star schema that, yes, has an increased volume of data, but believe me, this is the only way you can have a very, very quick report with a large data volume, because having a snapshot table with hundreds of millions of rows is really not an issue. The performance will be very, very good. The only problem is the complexity of creating and maintaining this snapshot table. That's the reason why we probably want to move this calculation outside of Power BI, because we don't want to create the snapshot table every time for all the invoices. We probably want to update this table in an incremental way. And this is possible only by using tools that are outside of Power BI. Power Query and DAX are not good to incrementally update a snapshot table. That's a problem we have. So conclusion, and then I'm open to your questions. The idea of this session is that I try to not reinvent the wheel. So basically, if I try to reuse common patterns that I have, common modeling pattern that I have, I can reduce the problem to a well-known problem that has been already solved, and then I can reuse my knowledge, existing formulas, trying to save time and to also leverage existing patterns that already have been tested for the performances, like, for example, the snapshot for the events in progress. So that's basically the idea. Try to not reinvent the wheel as the main message. Now I can take a look at the questions, because I was talking, but you can open the mic and ask me questions. So let's see. I look at that. I don't know, Halil, let's see if you have some question, or I can just read from the story.
Yeah, first of all, that was a great session, great technique, Marco. Thanks a lot. I'm checking the questions previously written into chat window. Yeah. There are cases where the payments are also made partially. Yeah. Interesting to see how it will be handled.
Yeah, so that's exactly my point. So in this particular case, I didn't have time to prepare all the demos, but the model that I created is the one to use in every case. So starting from the AR detail table, you have a partial payment. What happens? Well, you have to do exactly what we described in the slide. I go back to the slide where we described this. So I think it was at the very beginning, this one. So if you have a partial payment, you have a situation, let's see, like, let me do the math, like this one. So, sorry, look at this. So the last payment of Litver is 2,000, okay? And this payment of 2,000 made on the 1st of February 2025 is this one. Okay. This payment covered this invoice 002. But the remaining part of the invoice that has not been paid has been moved to this other row. So the total amount of the invoice 0002 is the sum of 4 rows. Okay, this sum corresponds to 16,000. Now, this 16,000 has been paid in 4 different lines with 4 different combination of payments and new payments. So you have to create this table. Okay, if you create this table, once you have this table, everything else works. The challenge is how do you create this table starting from the data that you have? But this is very, very dependent. Sorry, this is very, very dependent on the model that you have. This is an example, right? And you might have data in a different way. So if I create a specific solution for this example, it could be different in your case because you have a different association between payment and due payment and invoices. So I try to describe the worst case scenario. If I had to create the code for this scenario, I probably would try to not use DAX because DAX to solve this problem is complex. Whenever you have a solution where you have to get a value and then allocate this value with a technique like based on a first in, first out, something like that. That's because you don't have recursion in DAX. So it's very hard to get a value, then allocate and remember in the previous row and do something with the remainder of a previous operation. That's complex in DAX. If you use other techniques, you use a procedural language, is much easier, is much easier. So you can the goal is transform your data into the model that we described at the end, because solving the granularity problem, consolidating the data that way is the key to complete the report in Power BI without trying to write impossible DAX in a measure. That would be also very, very slow.
Okay, another question, but I believe it falls into the same category. Where is it? Sorry.
Overpayment for customer. Yes, it's the same thing. It's exactly that.
Yes,
exactly. This is another case that I have illustrated here, which is the case we have, for example. Oh, sorry. The case we have for, I think, this one. So we have 10,000 from the invoice 00. Sorry, not this one. The payment is 15,000. This one. This 15,000. Actually, this is not an overpayment. If you look at that, because it paid in December. It paid this due date. It was 15th of December. So let's say if this due date was in January, this would have been an overpayment. So you would have had a payment date that is less than the due date for that amount. The thing is, what happens if you don't even have any due date? So you receive money from a customer without having an invoice. Okay, that's another problem. That I don't know. So that's you probably have to create a dumb invoice. I don't know. This should be analyzed. But again, it depends on your source data. So it's something that I will evaluate case by case, always trying to let's say to create this AR detail as a goal for your measure.
Exactly, I agree on that.
Okay.
Okay, your last chances, audience. Please unmute yourself if you have a question.
Yeah. I'm reading in the chat window. In the real world, we also need to consider credit memo return payments as well. True, but yes, but it's just like another payment. If you think about the problem, you could always the goal for this analysis is to evaluate how late are the payments. So if you have like a credit note that will be used as a payment for a future invoice, that's just another kind of payment from my point of view. So it's something that you will adapt this way. So I don't think is a big issue. I think it's something that you will solve.
Exactly, they fall in the same category. Okay, I think we are done, Marco.
Okay.
Thanks a lot. It was a great session, great technique, great ways to solve these similar issues.
Okay.
Okay, let me stop the recording. Thanks
Okay.
everyone for joining us.
Okay. Thank you very much. It has been a pleasure. Thank you.
Thanks a lot, Marco.
Oh, by the way, I have to send you the files for the session. So if you want to share with the
Yes, I'm
the
going to
user group.
share these files when I publish the video on our YouTube channel. It will be available.
I will send you an email in a few minutes with the link to download the demo files and the slides. Okay.
Okay, that's great.
Perfect.
Thanks a lot, Marco.
Thank you very much.
See you.
Have a good day. Good evening. Bye bye. Bye bye.